Hi there, welcome to this lecture. In the previous lecture, I showed you some code and we set up your development environment and we executed that code. And I told you to not worry about what that code meant, right? Well, now it's about time we start diving into the details and understanding what some of that code was, and then we're going to work our way into more advanced concepts as we proceed in this course, okay? So let's get started. For this lecture, there's a source code available on the GitHub repository and you can access it from this link, okay? So just import that project called project 1 into Eclipse, and so you'll see the code that we're going to write in this lecture. So let's get started. The application that we're going to create is going to be a good end-to-end example where we read data from a CSV file and load it in a database, okay? And this is going to be a comprehensive enough example for us to talk about how this application would behave differently if we were to run it on a live cluster, okay? Right now we're going to be running this locally, but eventually I'm going to show you how you can run Spark applications on multi-node clusters. We're going to get into that later, but this will set up the ground for us to have that discussion. So let's get started. For every Spark application that you write, the very first step is to connect with something called the Spark master node. And we're going to talk about what that is later. But to connect with the master, you have to first establish a session. So that's what we're going to do here, create a session. And how do you create a session? We use this object called Spark session, and let's assign it to a variable called Spark is equal to new Spark session dot builder. So we build a Spark session, and then we give this session a name. So since we're going to be taking data from a CSV file and loading it into a database, I'm going to call this CSV2DB. Okay, and then the next thing is we specify where the master node is. In our case, it's just local. So we're going to call it just local host. Dot get or create. Okay. Now, of course, this is not compiling because I've got some imports that I need to bring in. So hover your mouse here. Notice it's saying import Spark session from org.apache.spark.sql. Okay. So let's do that. And that will bring in the object that we need. So here's a Spark session. We've established it. The next thing is let's figure out where we want to get the data from. So let me put a comment here, get data. So the way to do that is we can use a Spark session and we can do read, and then we specify the format of data that we want to read. So this is CSV data. So we do format CSV. Now it's important to note that other formats are also allowed, such as JSON and Parquet files, as well as XML. So the options here are endless. And then we specify whether this file has a header or not. Okay, CSV files could have headers or they could not have headers. So we have that option here. So we can specify whether the header is true or false. So in our case, and I'll show you the file in just a moment, it's going to be true. And then we do load. And then here is where we specify where the file is. So the file in our case is right here. Name and comments is what it's called. It's in the source main resources folder. If you open it up, notice it's just a basic comma separated values file. We've got a last name, first name, and comment. Okay, so this file does in fact have headers. So that is why we chose headers to be true. All right. And so where's this file? We specify the full path here, source main resources / name and comments is the file name .txt. Now typically in a production level environment, when we're loading files, we're going to be loading them from a distributed file system. Since this is a local example, we are specifying a special directory, but for real world data processing, we're going to need to specify a distributed file system here, such as HDFS, the Hadoop distributed file system, or something like the Amazon S3 bucket. We'll go into those examples later. Now, it's not enough to just read this file, right? We need to save it in some kind of a data structure. And the data structure that we're going to be using here is known as the data set with rows. So let's define that, data set. And in these angle brackets, the type that this data set supports is called a row. And typically, the variable name that is identified as the dataset row is the df, which stands for data frame. Okay, you can name this variable anything you want, but in a lot of the code examples that you'll see online as well as on the Spark website, they use this df variable to indicate that this is a data frame. Okay, so let's do the Command-Shift-O to bring in the imports. And notice it's bringing in from org.apache spark SQL.row. Okay, so make sure you get the right import there. So what is this DF? What is a data frame? A data frame is identified by this data type. And it is exactly like, I want you to think of it as a database table. It's got rows and it's got columns. So this data frame object, we can talk with it just like we would a relational database table. We can write select queries on it. We could do group bys, order bys, and I'll show you all of that stuff. Now there's a whole lot of fancy engineering going on behind the scenes of this data frame object because it is a distributed data structure. As a developer, we don't really think about it as much. We use it as if we were interacting with a database table, but there is a lot of cool stuff happening behind the scenes, and we're going to get into those details later. But for now, I want you to think of this as you would a database table. So now if we do df.show, right, this is going to display the contents of this data frame in the console. Okay, so let's right click and run this application. And of course, it has all this logging that it needs to do first. And there we go, we're done. So this is the data frame. Okay, it looks just like a relational database table. It's got 3 columns: last name, first name, and comment. You could choose to show a specific amount of rows. So here we've got 4 rows. If I wanted to only show 3 rows, I could just put 3 in these parentheses. And when we run this application, we'll only see 3 rows of the data frame. Now, typically when you're working with batch applications, and of course Spark is meant for batch applications as well as real-time streaming, there is this concept of transformations, okay? When you need to change the data in one way or another, and you can use this API to do that. So for example, we've got the first name and the last name. What if we wanted to have a new column called full name with the concatenation of the first and last name together? How would we do that? Well, we can do it actually quite simply using the df object. We could do df.withColumn, and then we specify the new column's name. So the new column that we want is going to be titled full name, and then we specify the actual column. So we could do df.col, C-O-L, or col, however you want to pronounce it, and then we specify the particular column. Okay, so right now I left it empty, but I could say that I want to have last name also go into this column. So here, when this runs, it's basically going to take that df object, the data frame, and create a new column called full name and give that column's value to be what is in the last name. Okay, so if we were to print this object out now after this, we would have a new column with full name being the title of that column, having the last name in it, along with all the other columns such as first name, last name, and so on. Okay, so of course that's not what we want to do. We want to concatenate the values of the first name and the last name and give it in this full name column. So how do we do that? Well, we could use something called the concat function. So let me show you how to do that. So we do concat, and then as the arguments to the concat function, we specify the columns values that we want to concat. Okay, now again, this is complaining because we haven't imported it yet. So if we do a Command-Shift-O, we actually can't bring this in directly like that using Command-Shift-O because the import that is required is actually a static import. Okay, and that import is right here. I'm just going to paste it like that. So it's import static, and then we do org apache spark.sql.functions.concat. Okay, and now as you can see, it's compiling. So this function, of course, returns a column. If you hover your mouse over it, notice it returns a column object. So it does give as the second argument what this method requires, but right now it's not doing anything useful. So let's actually specify the particular columns values that we want. So we want to concatenate 2 columns. We can use concat, and we can say df.col, and we specify the first column, which is last name. Okay, and then we separate it with a comma, and then we specify the second column. So it's going to be df.col, and that is going to be first name, like that. So now it's going to take the text in the last name column and concatenate it with the text in the first name column. okay, combine both of these together and put it into a new column called full name. Now, of course, we don't want to just club both of the texts together because, you know, it won't be very reader friendly. So let's separate it with a comma. We cannot do something like, we can't do something like this where we put a comma like a string as you would a normal string. You can't do that. We need to use something called a lit function, okay? And that basically is short for literal. So when we have literal text that we want to be part of a value for a given column, we could do lit and specify in the argument the text that we want to be treated as the literal, just like that. And of course, this is also coming from this static import from the functions package, so, or the functions class rather. So instead of doing concat specifically, I'm just going to do a dot star, a wildcard, to bring in all those imports, and now it is interpreting lit as an actual function that we can use. Okay, so what goes in here? We can just put a comma and a space. Okay, so it's basically going to concatenate this column's value with this string literal, which is a comma, and then finally this column's value. Okay, so we get the last name comma first name in the full name column. Okay, that's what the with column does. So this is basically a transformation, isn't it? So let me write that here, transformation. Now we haven't transformed anything yet. Okay, if I do a df.show, let's do that, df.show here. Let me comment out the first show so we only get one table on the screen. This doesn't actually change the data frame structure. Let me prove it to you. If I right click and run as Java application, I'm going to zoom ahead so that we don't waste time looking at the log entries. Notice the output of that is still the same old table. We don't have the new column full name with the contents of the last name and first name column. We don't have that. So what does this tell us? This tells us that data sets are immutable structures, meaning they cannot be changed. They can only be recreated. So we haven't modified this df structure directly. What we need to do is we need to assign it back to the df like that. And now this is officially a transformation. We are transforming the data in the data frame object. Okay, so now if I right click and run as, you will see the new column. Let me zoom ahead in the video so that we don't look at those logs. And there you go. Notice this is the modified table. We've got a new column called full name, and the contents of this column are the last name comma first name. So this transformation was successful. Let me expand the screen here so that you can see the full line of code. So the with column method takes in two arguments: the name of the new column that we want to create and the column from which you want to pull the value that's going to go in here. So that's being pulled from this concat function that combines the values of those two columns, okay, and returns a column object. Now let's say we want to do another transformation where we only want to see the comments that have numbers in them. So let's view our file again real quick. Notice that this entry right here has a number, okay, as well as this one right here. Here's another number. So let's say that we only want to see those rows that have comments with numbers in them. So I expect to see the record for Milford Ingram and Fen Dong. How would we do that? Well, it's actually quite straightforward. Let me just put comments here saying that we're about to do another transformation. And what we could do is we could do df.filter. And in here we have to specify a condition. So we could do df.col and specify the column that we want to filter on, and that is going to be the comment column. And then we call a function called rlike. Okay, so SQL has the like operator, and it also, a lot of databases also support something called the regex like, and that's used for regular expression matching. So rlike here, this function basically is used to match against regular expressions. So in here, in quotes, I can put a regular expression. So to match against sentences that have numbers in them, I can use the two slashes with a D plus. Right, this will only match the sentences that have numbers within them, the digit D, that's what that stands for. So again, to actually do the transformation, I need to reassign it back to the df object, like that. And now if I do a df.show, I should only see the record for Don Feng and Milford Ingram, okay? So let's right click and run that. And scrolling up, you'll see the modified data frame. Notice it only targets those two records, Milford Ingram and Dong Feng. Both comments by those authors have numbers within them, so we're able to target those records. And we have transformed the data in the data frame object. Now, if you want to do an order by, you could do .order by, just like you would in SQL, and then we specify the column that we want to order by on. So we do df.col. There's a shorter syntax to refer to the column, but we'll get to that later. And then we specify the column that we want to order on. So let's order by last name. And then we can also use descending or ascending. So if I want to do ASC, ascending, then the first record that is going to be as part of this data frame is going to be Dong, because D comes before I. So let's test that. Right click, run as Java application. And scrolling up, there we go. We see Dong first and then Ingram. Now there's a lot of method chaining going on here, so it's good to split the lines so that it's easier to read. Okay, so I typically do that. I can do the order by here on the second line to make it easier to read. As a matter of fact, you can combine this filter with the expression on the first line. So let's just move this as part of that. So now this entire thing could be thought of as one data frame transformation. Sometimes it's helpful to break things on 2 or 3 different lines. This is still short enough for the average Spark developer to grasp, okay? But in the beginning, you may have to split things in multiple lines, and that's totally okay. It depends on your coding preference, really. You can also, of course, assign this to a new data frame so that you don't mess with the original data frame object. So if I was to define a new data frame, I could do dataset row, and I'll say transformed df, and then assign this df to the transformed df like that, okay? But I'm okay with the way it was. I just wanted to show you that that is certainly possible. Now to complete this example, I'm going to save this data frame, modified data frame, into a database table. So instead of showing the contents, I don't want to show anything. I actually want this data to be saved into a database. So if you're familiar with JDBC, the code that I'm about to paste is probably familiar to you. Let me paste it right here. We're using a PostgreSQL database driver, and we're giving it the properties such as the driver, right, which could be found as part of the source code in the POM file. I actually have the Postgres driver version here, and the dependency is down here, the PostgreSQL dependency. So this code should work for you. You just need to start a local instance of the Postgres database, which you can download very easily from the PostgreSQL website. Now this properties, these are coming from java.utils. I'm just going to do a Command-Shift-O to bring in the import. And then to actually write to the database, we can use the data frame df.write, and we specify the mode that we want to write. So the mode is actually going to be save mode dot overwrite. Okay, this allows us the ability to rerun this application and it'll just keep rewriting into the table that we specify. Okay, and then we do .jdbc, and then we specify the database URL connection, which is right here, db connection URL. Paste that, and then here we specify the table name. So let's just call this project 1, since that is the project that we're using. And the connection properties is just the prop object that we've populated up here, just like that. So let's save this file and right click, run as Java application, and see if this data made it into our table. I already have Postgres installed on this system, so we'll be able to log into Postgres and check. Okay, so looks like there were no errors. Let's log into Postgres. I've got a pgadmin4 tool that we can use to connect to the database. And notice the username is Postgres. This is the default username. And when you set up Postgres on your system, it asks you to choose an administrator password. So to keep things simple locally, I just chose password to be my password, but you can choose your password to be anything, okay? So let me bring in the pgadmin tool. Let's connect to the database. and the database name is called course data. How do I know that? Well, in the code, notice the URL is course data, okay, localhost course data. So that is the database name, and the table name is project 1. So let's open up the query tool and do a select star from project 1, and I should see those records. And boom, there you go. We see our data that we pulled from the CSV file, and we're only seeing those 2 records that we want, the records with the comments with numbers by Don Fenn and Milford Ingram. Okay, so hopefully this was a good comprehensive example of taking data from a file, doing some transformations with it, and then loading it into a database table. So this is a nice end-to-end example of just using sample data. But if we had a massive file, let's say terabytes worth of data, and we were connecting to a distributed file system, this code that we've written here would work pretty much the same way in a distributed cluster. So we didn't have to even think about creating multiple threads and forming multiple connections with the database. Spark takes care of a lot of that overhead. So how exactly does it do this? We're going to talk about that in the next lecture. Okay, we're going to look at this code with new light and try to understand how Spark would handle this kind of a program in a distributed environment. So stay tuned. I'll see you in the next lecture.